Hello, in this video we will show how to use the z-value of normal distributions and with R. So we start with a simple example. So suppose we have measured the heights of 100 people and the mean height was 170 cm and the standard deviation was 8 cm. So now we have several questions. So what is the probability that a randomly selected individual will be shorter than 160 cm? And the second question is taller than 185 cm. And the third question is the probability between 160 and 185 cm. So like these typical questions, the very simple usual way is to convert the height into a number of values called z. So z is the random variable numbers along this axis in the standard normal distribution density function. And z is also the number of standard deviations in this figure, because standard normal distribution has mean 0 and standard deviation 1. So for example, if z is here, for example 1 minus 1.5, then we can calculate the cumulative probability less than this value in total normal distribution, standard normal distribution. And in R, we have very simple function called p-norm, can calculate the cumulative probability from the left infinite to this z value. So first we have to think about the conversion of the height to a z value. So the form is random number minus the mean value of this random number and divided by the standard deviation. So in this example, we will first calculate 160's z value on standard normal distribution. So we use 160 minus 70 because this is the mean value and divided by the standard deviation. So this z value is minus 1.25. So what this means? This means the height of 160 cm in a normally distributed heights values with the mean value 170 and the standard deviation 8. The z value alternative in standard normal distribution is minus 1.25. And this value is also set about minus 1.25 times of the standard deviation in the standard normal distribution. So next is quite easy. We just use the function called p-norm minus 1.25. So the result is 0.1. Here is minus 1.25, and if we take a vertical line, so the area on the left side of this value under this curve is about 0.1. So we show in RStudio p-norm minus 1.25, 0.1. And in a similar way, we can calculate and convert 185 to the z value. So it is 1.837. And because the question is larger than this number in height, so we have to use 1 minus the p-norm of 1.875. So 1.875 is around here, because the p-norm is to calculate the left side area. But larger than 185 means we have to calculate the area on the right side of this z value. So we have to use 1 minus p-norm 1.875. So the probability of standard normal random value larger than 1.875 is 1 minus p norm 1.875. So it's about 0.03. So this is to say about 3% of the people higher than 185 cm in this data example. So the third question will be very clear. The height between 160 and 185 is just the difference between these two say values p norm function. So we use p norm 1.8375 minus p norm minus 1.25. So it is about 0.86 or 86%. So in the figure, it is just like between the green area. If this is the say value for 1.875 and this is the say value for the minus 1.25. So this area between is for height between 160 and 185. Thanks for watching.